Okay, so on the previous assignment, you're introduced to equations in two variables. And I believe the equation that we used was x plus y equals 5. Okay, one of the most obvious solutions to this equation is x equals 2, y equals 3. And we can use an ordered pair as shorthand to write that particular solution. Now, we're going to learn now how this ordered pair, this solution to this equation, can be graphed. Just like you can graph an individual number on a number line, you can graph an ordered pair on this thing, which, by the way, I have a separate short video that discusses why this is not a graph, like a lot of people call it. It's used for graphing. But this is called an coordinate plane. A coordinate plane. It's a plane used for graphing coordinates, specifically x coordinates and y coordinates. This horizontal line, it's actually an imaginary line, but we put it there so we can understand where it is. This is called the x-axis. The x-axis, that's this, and this is this vertical number line is the y-axis. The y-axis. Okay, there's also a special name for the point where the x-axis intersects the y-axis, and that is called the origin, where things originate. Notice it's called the origin. Okay, now, well, I'll write that up here. Okay, so if we want to graph this solution to this equation, we just find where x equals 2, so we get a 2 on the x-axis, and 3 is the y-coordinate, so we go to 3 on the y-axis. So we're at 3 on the y-axis and 2 on the x-axis. Where those meet? They meet right here. So this is the point 2, 3. Okay. Let's take another equation. Let's say we have x minus y equals 5. I might need a larger coordinate plane for this one, or one that includes higher values of x and y. Here's 5 on the x-axis. Here's 5 on the y-axis. Okay, a solution to that might be x equals 7, y equals 2. So we would find 7 on the x-axis. There's 7 on the x-axis. And here's 2 on the y-axis. And where do they meet? Boom. There's a point 7, 2. Okay, how about the equation x plus y? Oh, let's even more fun. 2x plus y equals 5. We don't need the big one for this one. Okay. I think I can pause the video and see if you can think of a solution or two to this equation. Okay. One solution would be x equals 1, y equals 3. But I'm going to find one with x is negative. X is negative 1. And y would have to be 7. Let me pull out that coordinate plane that goes up to 10 for x and y. Okay, so we have negative 1 on the x-axis and 5, 7 on the y-axis. So this point right here would be where x equals -1 and y equals 7. If we wanted to switch that around, it wouldn't be a solution to this equation, but I'll just get rid of that. How about we take the point 7, -1? We'd have to go to 7, 1, 2, 3, 4, 5, 6, 7 on the x-axis, and negative on the y-axis. That will be right there. And back here, these points, x and y, are both negative. So, for example, -2, -3. Back up 2 and go down 3. It's pretty much that simple. Now, how about if one of the coordinates is 0? Let's say 0, 3. The x coordinate is 0. The y coordinate is 3. Well, it may be obvious to you. Well, 0 on the x is right here, and 3 on the y-axis is right here. So that point would be right there, 0, 3. And let's see, what would this point be right there? That point, well, where are we on the x-axis? The x-coordinate is -2, and the y-coordinate is 0. That's how you graph solutions to equations in two variables. The whole purpose of the coordinate plane is for graphing solutions to two variable equations.